So my name is David Tsai. I run the marketplace and data platform engineering teams at Convoy. Today I'll be talking a little bit about what Convoy is, how we use machine learning, and how we leverage Amazon SageMaker to help us achieve our goals. So why trucking? Where I'm based in Seattle, the slides actually aren't. Is it? Oh, never mind. Okay. We're actually a Seattle-based startup, found a little over 3 years ago. What Convoy is trying to do is reinvent how trucking is done in North America and beyond. A simple explanation of what we do is we're kind of like an Uber or Lyft for commercial trucks. These are the big rig trucks you see on the highway, the big 44-foot long trucks. As a startup, we've been scaling pretty rapidly in the 2.5 years I've been working at Convoy. We've gone from a team of about 20 to a team close to 400 now. So why trucking? So why is this space important? Where I'm from in Seattle, software engineer is actually the most common job, in many part thanks to Amazon and Microsoft. That's actually where I started my career as well, working at Amazon in Seattle back in 2004. But throughout the rest of the country, a truck driver is actually the most common profession, and it's the most common profession in 29 states. And this doesn't even include all the kind of surrounding related jobs that are related to trucking, such as transportation coordinators, brokers, and other roles to facilitate the actual movement of freight throughout the country. This is a massive kind of operation at a massive scale. So about $1 trillion is spent on freight in the United States every year. What's amazing is about 80% of this spend is spent on trucking. That's 4 times more than all other modes of transportation combined. So for example, everything you see in this room most likely went on multiple truck trips before it ended up here. So the supply side of trucking is actually pretty fragmented. There's about 3 million trucks in the United States. And the top 20 largest trucking companies only control about 12% of this capacity. Most of the capacity of trucks belong to kind of these mom and pop carriers. There's a lot of small operators that operate just a handful of trucks. So it's kind of like the opposite of the 80-20 rule. Let's dig into one of these companies and to kind of get a better idea of how trucking works. So here we have a single company among 1 million other trucking companies. There's about 3 million truck drivers. And so how does a small company like this one find work from shippers like Unilever, Kroger, some big brands you may have heard of, other brands you might not have heard of, to small companies, small factories producing goods that need to be moved. Overall, there's about maybe 100,000 of these shippers. So how does a small trucking company like that get work? Well, he has to work through brokers because he doesn't have the resources or skills in order to get the work from those shippers. So usually brokers are the ones that do the sales, marketing, customer support, and billing on behalf of these trucking companies. Another key function that they provide is they aggregate demand from multiple shippers and then dole it out to trucking companies to actually service the freight. And there's thousands of these brokers operating in the country, some large, some small. And the way these brokers traditionally work is kind of through pretty traditional methods of phone, email. So when a shipper wants to ship something, typically they'll email or call their broker. The broker will then call around to find a truck to service that shipment. And then the trucking company will then call or text their drivers to actually assign the work. And that's kind of like the flow of information. There's a lot of manual power, a lot of manual work. And many of these brokers employ thousands of operators and agents hitting the phones, emails, to coordinate all this freight being moved around the country. And the flow information here actually goes both ways, right? When the driver is actually delivering the shipment, they are texting or emailing their trucking company dispatcher the status of the shipments, and then the trucking company relays that information to the broker, and then the broker relays it back to the shipper, all in a fairly ad hoc kind of manner using human power. So a key part of what we're trying to do with Convoy is to kind of replace the traditional method of brokering by creating an online digital marketplace. So instead of having humans make the connections between shippers and trucking companies, we want to create an online marketplace similar to maybe like Airbnb or Craigslist, right? Or also other marketplace businesses where we can start connecting the two sides and allow them to transact independently without a middleman. So what we've been able to do is create a large network of connected trucks. Here's our screenshots of our mobile application that the trucking companies are using. On the left, we have a screenshot of a shipment detail kind of screen. It's an example shipment that a truck driver can take. So you can see it provides kind of the pickup and drop off location and some details about the shipment, and also the price in which we're offering it. The truck driver can look at this and directly press that green button and take the job, and it's his job. Or if he doesn't like the price, we also provide a second mechanism for him to submit a bid to see if they can get a slightly better payout. And that's actually one of the ways we use machine learning, is to help us automatically decide whether or not we want to take that bid or wait to see if someone else will go ahead and take it at our proposed price. The middle screen there shows another key feature for our mobile application. So part of Convoy, we also are responsible for the servicing of the shipment. And there's a whole workflow that needs to happen in order to service a shipment. And one of the key parts of that workflow is a document known as a bill of lading. So a bill of lading is a document that needs to be signed when a shipment is delivered to the recipient. It's sort of the proof that the goods were delivered successfully and in good condition. And this is a particularly important document because it's what allows the truck driver to get paid, essentially. It's proof that they successfully delivered the goods, and they can then send that document to their broker. The broker will, a traditional broker will process that manually, usually by review the documents, and then pass that information along through an invoice to the shipper. The shipper will then pay the broker, and then the broker will then pay the trucking company. That whole process involves multiple humans and can be quite an arduous process that can take up to 30 days to 2 months to actually get money in hand after doing the work, delivering a shipment. So with Convoy, what we've done is we made it so that the truck driver, as soon as it's signed, he can take a picture of the document and upload it to our platform, and we immediately process it. And if they do everything correctly, we'll then pay them within a matter of days rather than months with a traditional broker. And then on the right, we have kind of a screenshot of our fleet management tool. This is a screen in which carriers can use to add or remove drivers or kind of manage their equipment so that we know what type of work the carrier can handle. So how do we apply machine learning at Convoy? So as a marketplace, our marketplace is a little bit different than many of the other kind of technology marketplaces that you see out there, like Airbnb or eBay. Convoy is actually a broker, so we take on principal risk when we take on a shipment. We actually sell trucking capacity before we actually have it. So to take a concrete example, let's say a shipper comes to us, they want to ship something from here in Las Vegas, let's say back to Seattle. Convoy might quote them, we'll do it for $1,000. We give this quote even though we don't actually have a truck, right? We have to actually, if they book it, we have to actually go into our marketplace through our mobile application and find a truck driver that will do that job. So we take on the risk of losing money if we're not able to effectively broker that deal with a positive margin. This is pretty similar to how like investment banking works. But by taking on this principal risk, it also creates a lot of interesting kind of problems and opportunities to use algorithms to make this process more efficient. So one of the key ways in which we use machine learning is to do price prediction, like I was saying earlier. We use it to forecast both short-term and long-term prices to figure out how much we think it'll cost us to buy a truck if a shipper books a shipment with us. From that cost prediction, it allows us to then accurately quote shippers. And we have to provide these predictions both on a short-term basis, a couple days in advance, to up to a year, where some shippers like to negotiate long-term contracts for freight volume for us. And another big way we use machine learning is for relevance. So if we showed every shipment we get in our network to every single truck driver, it would just be too much information. So we use relevance to try to predict which truck drivers do we think is the most likely to want a particular job and to be interested in it. This allows us to target specific truck drivers with relevant work so that they can always have a positive experience when they open our application and see jobs they're interested in. We can also feature kind of jobs that have high relevance score more prominently in the app, or even send them push notifications, hey, here's this job, it's from Seattle to Los Angeles. You'll be really interested in that one. Another big area we use machine learning for is automation. So like in the bill lading kind of process that I talked about earlier, in order to process those documents automatically, there's a lot of opportunities to use machine learning to help classify those documents and kind of remove the human element in reviewing those documents. We also use machine learning to automate operations in our marketplace to make decisions, such as the other example I mentioned earlier on whether or not we should take a bid or wait to see if we get a better bid. So we use machine learning to kind of calculate the probabilities of us getting a better bid, and from there we can decide whether or not we should take the bid we have in front of us. And lastly, the other big area we use machine learning for is strategy. Trying to figure out like what kind of shipments we should go after. As a startup, we kind of have to focus our efforts at kind of the highest value targets. So it's really important that we can understand the dynamics of our marketplace, understand seasonality effects, such as when produce season hits in North America, the freight patterns change pretty dramatically. All the southern regions that are growing produce start being really attractive places for truckers to go, and people don't really like kind of leaving those regions. So we use machine learning and data science to kind of understand those effects so we can plan our business strategy accordingly. So how do we use SageMaker to kind of enable all of this? How we ended up adopting SageMaker is also a pretty interesting story. So being a startup, when we first started using machine learning to tackle our business problems, we started out with some pretty basic models, right? We started out essentially with like linear regression models. We would try some simple features, train it, and kind of deploy and kind of iterate from there. And typically we would do our research in Python. A data scientist might do their research in Python, and then an engineer would take the results of that research and re-implement it in our product with our production tech stack, which is in JavaScript, TypeScript, so it was a pretty cumbersome process. So after going through this iteration for maybe a couple months and creating increasingly more models and more complicated models, I was sitting next to one of my teammates, Logan, who's a machine learning expert on our team, discussing like how we could potentially streamline this process and make it better, and kind of threw our hands up, like there's got to be a better way. So I type into Google, machine learning SaaS or something like that, machine learning cloud, and it just so happens that Amazon had a press release that day announcing the launch of SageMaker. It was like really fortuitous timing that like at that moment that Amazon had launched SageMaker. If they had launched maybe a week later, we might have started either exploring other vendors or most likely started building our own infrastructure. to solve our specific needs because there wasn't really anything else out there that did quite what we wanted. So sometimes timing is quite important. So good job, Amazon SageMaker team, for getting the release out quickly. So on a typical product team that's kind of employing data science and machine learning, usually there's a wide range of kind of skill sets along kind of these two axes among various team members on a team. So on the very left, we have kind of the traditional software engineer who spends most of his or her time building software, maintaining software in production, and kind of creating new products. And then we have a data scientist who spends most of their time trying to extract kind of actionable information from data, right? They're spending their time doing a lot of research, training, looking at data sets, analysis. And usually various team members have various levels of comfort and skills along kind of this axis. So before we had this infrastructure, it would typically take two people to train and deploy a model. We would have a data scientist kind of do the research, train their model, and kind of try to get the results that we were looking for. And then we would have to involve a machine learning engineer that has to work with that data scientist to actually productionize that model, right? In our case, it meant re-implementing the model in our production stack. And usually, you need two people that kind of have some overlap skill sets so they can communicate effectively with each other, right? The data scientist has to have some idea of how the production system works. Otherwise, it would be really difficult to understand the limitations. The machine learning engineer will need to have a pretty good understanding of how the model works in order to correctly bring that model to production without creating errors. So this is generally a pretty time-consuming endeavor and requires a lot of engineering time and resources. So that's essentially what we wanted to use SageMaker to do, is to see if we can improve on this situation. So with Amazon SageMaker, what we've been able to do is sort of create this situation instead, where either an ML engineer or a data scientist, anyone with kind of skill sets along this spectrum, can independently build and train and deploy a model and experiment much more rapidly. This saves a lot of engineering time, saves a lot of kind of iteration time, allows us to innovate more quickly by empowering individual team members on our team to work independently, try new ideas, take on new risks without having to bring in the resources of an entire team. So that was essentially our goal with kind of using SageMaker. I think we're pretty close to kind of this ideal. We still have, there's always more things to streamline, but I think we've made pretty far along with kind of trying to realize this. And I'll go into kind of like the specifics of how we set up our infrastructure. So at the core of our infrastructure is we have this kind of template project for deploying models. And that template project will contain like all the infrastructure configuration, all the boilerplate kind of code and configuration to deploy models. And at the very heart of it is kind of this scaffold template of 4 methods. So in order to deploy a model into production, a data scientist now only needs to implement these 4 methods. So the load model method essentially is the method that will take your training artifacts. After you train the model, usually it produces some artifacts depending on what kind of algorithm you're using that can be loaded into the algorithm. So this method is a pretty simple method to implement. Usually it just involves reading the file, transforming it into whatever format your model wants the data to be in, loading it into memory, and then returning it. We then take that loaded model and then pass it to the make prediction method. The make prediction method on the bottom there is the method that you need to implement to actually return an inference. So the model is passed into that method. And then the two middle methods there, the validate input JSON data, takes in the JSON request input, and it's the kind of a last ditch effort to do a sanity check on the data. So as a data scientist, you want to implement any error checking to make sure the data is in the shape and kind of has the semantics you're expecting, and to throw any errors if it's not. Usually it's a pretty simple method as well, depending on how complicated your input features to your model is as well. And then this third function from the bottom is the make input features function. It also takes as input as an argument the JSON input, and allows you to do any additional feature engineering you want on your data set, whether or not you want to do averages of numbers or other kind of statistics or any other kind of feature engineering. You can implement those additional feature engineering kind of logic here, and the final result is what's passed into the make prediction method. So here's an example of an actual production implementation of our make prediction method. So you can see here, it doesn't take too many lines of code to actually implement. So as a data scientist, this makes it really easy for you to focus on extracting insights from the data rather than figuring out how to get it to production. So a quick explanation of this code is, it's taking the model that's been loaded from the load model method. It's taking the input data and transforming it using a Python library into a vector, and that vector is what's passed into the actual prediction algorithm. The prediction algorithm makes a prediction, and then we JSONify results and return it back out to whoever is consuming this inference. Here we have an example kind of helper method. Oh, we got cut off there, didn't it? That deploys, that actually creates and deploys the input, the endpoint for our machine learning model. So essentially, we built out a library of helper methods similar to this one to make it really easy for data scientists to interact with the SageMaker. So at the end result of executing this function results in a production model being deployed. So here you specify some configuration, some labels, you specify where your model is located, and then kind of our infrastructure kind of takes care of the rest. As long as you're following our template pattern, it will automatically take your project and deploy it into production. And here's what kind of like the host architecture looks like once it's been deployed. So the model artifacts and kind of training data that produce those artifacts is packaged up along with your implementation of the template for template functions. It's packaged up, uploaded into S3 automatically, and then Amazon SageMaker actually will take care of mounting your S3 files as a file system within your Docker container so that it can have access to the models. And then from there, we have a base Docker image that has all the necessary runtimes to run the models. So it includes a Flask web server, Nginx to kind of balance the work among different worker processes. And then as well, of course, it includes your model implementation from the template and the artifacts, and allows the client to then begin making API calls against a single endpoint that's completely abstracted away from the user. So you can run one container this way, or there could be hundreds of containers all be within the SageMaker kind of purple box there. Here's an example of one of the config options that goes into that create endpoint API. So it allows you to give your a variant a name. What it does is it allows you to run multiple different variants of your model. So you can actually either, if you're running a test, you can direct a small amount of traffic to your new version of your model before kind of sending all traffic towards it if you want to do some canary deployments, or if you're just testing out a new algorithm and you want to see its performance in production. The variant configuration that's provided by Amazon SageMaker makes it really easy to specify the weight and the number of instances you want running that variant. So with this infrastructure, what it has allowed us to do is allowed the data scientists or whoever that's working on the machine learning model to iterate really independently. So for example, they could change the underlying algorithm behind a model without letting anyone know. No interface changes, you can go ahead and make the change. We also, as part of our infrastructure, have continuous deployment hooked up. So you can make the change, commit the code, and deploy a brand new algorithm within a matter of minutes. They can add or remove features from a model. That's the feature engineering method I was talking about earlier. Allows you to implement brand new features from your input data without making any changes. You could deploy multiple variants of a model we just went over. We can increase or decrease the scale in which you run your model just by configuration change. We can even generate new input data into our models as long as they're static. So the reason why we can do this is because when we train our models, we create all these artifacts. And for most of our models, we retrain them automatically on a daily basis. So we can actually package input data into those model artifacts directly, rather than getting that input data from production. So for example, if one of our models used the weather as input, we can pre-compute and look up the weather for the weather forecast for the week, include that as part of our model artifacts, and deploy that so that we don't have to fetch that information in real time. This allows us to experiment a lot with new features without having to make interface changes and get new input sources. Another really cool thing about this is we can roll back to any historical version of any model. Every single model is packaged up and stored in S3. So this includes all the training artifacts, the source code of the model. So you can easily pick any date and roll your model back to that date. Really useful for when you deploy bugs. And we can run multiple models versions of a model simultaneously. And we can do all of this with minimal engineering involvement, which is a huge change from how we were doing things before. So here's a quote from one of our data scientists who was instrumental in helping us build out this infrastructure. It's essentially allowed him to really work independently and not get blocked by engineering and kind of work more quickly. Cool. Thanks everybody for listening, and happy to take any questions now, I think.
Yeah, and for questions, if you're wondering what this beautiful slide is up here, if you go to slido.com and put in startup, put in your question there, you can upvote questions, and we'll just take the top questions from here. So, question is, does Convoy integrate with e-commerce platforms like Shopify? How do you help Shopify sellers?
So we're actually completely a B2B business, so we don't have any consumer-facing, other than our mobile application. The truck driver is the closest consumer-like kind of entity we have in our.
So essentially,
business.
behind the scenes, unrelated Shopify products are being shipped around and likely being used by Convoy.
Yes, exactly. Like I would say we're a little bit more upstream from Shopify. Like in the actual production of the goods that are being sold on Shopify, those goods likely went on multiple truck trips in order to land at the actual seller. That's maybe, I don't know if Shopify uses Amazon fulfillment or not, but we might be shipping to Amazon fulfillment centers or their own independent fulfillment centers. We don't handle so much the last mile consumer.
You handle in bulk, large scale.
Yeah, exactly. Think like the amount of goods that would fit in this entire kind of area.
And you guys are currently in the US. Is it just US? Do you have plans to roll out Convoy globally? Where are you today?
We're currently in the US, but we're pretty ambitious. Eventually, we'll likely look to expand beyond.
And is trucking industry the biggest in the US, or what do the markets look like globally?
I actually don't know offhand what the specific stats are globally, but US is definitely one of the largest markets. China's probably pretty large as well. It's pretty big throughout the world. Europe has a large market, South America has a large market. I don't have the exact figures though.
And we heard a fun statistic today that the largest consumer of romance novels are truckers, which is great to know. Next question on this is, how many people are currently employed in the brokerage industry?
It's a good question. I actually don't know offhand. There's about 15,000 brokers. It's definitely in the hundreds of thousands, if not millions.
What are any stories coming back from truckers after using your platform? Like any stories from the road, essentially?
One thing I've learned when working in this, I had no trucking experience prior to working at Convoy. So I don't know about you guys, but I don't pick up phone calls if I don't know the number. If I get a phone call that has just a number on it, I never pick it up. I let it go to voicemail. But that is completely not true with truckers. They will pick up your call, like almost without fail, which is one of the most awesome things being like in product, right? To be able to call your customers and have them pick up and give you instant feedback. So anytime we have any questions about our product or any issues or trying to debug something, we could just pick up the phone and call them, and 90% of the time they pick up, which is like pretty awesome kind of situation to be in.
Any latest features or releases to SageMaker that you or your team are excited about?
I'm actually not too in tune with the upcoming roadmap, actually. So.
Well, there's always a lot on the works. There's always new stuff coming out. What about testing your models? How do you do A/B testing? Can you kind of walk us through how you test these?
Yeah, I do. So I guess there's two main ways. One is kind of for supervised learning, we reserve a test data set to validate if a model is better, right? So that's like step one. And once we deploy to production, we usually A/B test as well. For that one, we built out our own kind of experimentation framework internally that runs parallel to our SageMaker infrastructure that allows us to kind of record the metrics and then tie it back to our business metrics to see if the model is doing better. So it's a completely separate kind of framework that lives alongside SageMaker.
And how much data do you need to do one of those tests? Have you figured out how much is enough for
It depends on the problem, right? We use models for quite a few different use cases. One thing in trucking, though, is that we generate a lot less data than a consumer internet company might that's measuring click streams or something. They're generating billions of data points per minute. With trucking, each data point is probably a physical thing, physical truck moving throughout the world. So the volume of our data is much smaller. So sometimes it does take us, a little while to get statistical significance on our experiments.
Do you use all elements of SageMaker? Like, do you do the building, the training, and the deploying through SageMaker, or do you just take some pieces of the service?
We take some pieces of the service. I don't think we're using the whole thing. We do use like kind of the Jupyter notebooks occasionally, but the primary way we use it is for deployments at the moment. We might look into, I think there's a couple features we're looking for before we would use it for the training aspect.
It'll definitely speed things up, so that'd be great.
Yeah.
How difficult was the initial setup and configuration of SageMaker? So you loaded that web page, you saw the announcement. How long did it take to go from that announcement to getting a test environment up and going?
Oh, it's a matter of days before we had a prototype. Actual production model, I would say probably on the order of 2 weeks, 2 to 3 weeks.
You would have taken that time just setting up a pipeline to start doing the training in 2 weeks if you had to do it by hand.
We didn't start out with the template, of course. We started out, okay, let's take a single model, move it to SageMaker, see how that works out. From there, we were then able to start seeing the patterns and start kind of generalizing the patterns. So it was a pretty iterative process.
Do you use PMML?
I'm not actually familiar with what that is.
What is PMML?
I didn't ask it, but I know what it is. It's predictive model markup language. It's a way to describe machine learning models in an XML format. I don't know who asked it though.
Well, you couldn't hear the answer to that.
I couldn't
So
hear
the answer is
question.
no. That's a safe answer. What about the startup scene in Seattle? What's it like in Seattle? You're basically building a startup where you have companies like Amazon, Microsoft there.
Yep.
Can you talk a little bit about building a company in that city?
Yeah, I think it's a great environment to kind of hire because we have such a great talent pool. And oftentimes we are competing for talent against the big tech companies, Amazon, Microsoft, and all the satellite offices from Silicon Valley in our area. So usually it's a matter of whether or not the candidate wants to work at a startup. If they're interested in kind of working in startups and kind of working in a fast-paced kind of environment and trying to kind of develop something new, we found I think we've been pretty lucky in being able to successfully recruit.
Yeah, I mean, if you have an interesting enough product that is making a big enough impact, it's easier talent to really help solve that. So.
Yeah, I'm not sure how it compares to Silicon Valley. It's been a while since I've been down there. But I would imagine there's a lot less competition for talent between startups. So we're mostly competing against the big tech companies. So it's usually more of an apples and oranges. It's pretty rare that someone is considering us and another startup because there aren't that many kind of big upcoming startups in Seattle.
Are you planning on trucking talent into Seattle?
What talent in Seattle?
Are you planning on trucking talent into? So the next question is, what is your spend on SageMaker Bill? So you have this up and going. What are you spending within the organization on the service?
I actually don't know off the top of my head how much we spend specifically on SageMaker, but we have a pretty big service. But like I said earlier, our QPS is pretty small relative to most tech companies. So our infrastructure spend relative to per unit of revenue. Our per unit of revenue is one shipment, which costs on the order of thousands of dollars, right? Whereas the per unit revenue for an ad would be like one ad, right? So the spread there is definitely huge in terms of what percentage of revenue we're spending on our infrastructure.
I mean, one nice thing about SageMaker is it will, when you do training with it, it'll spin up the cluster and then tear it down when you're done. Yeah. And that's that is the biggest cost of machine learning. And just simply forgetting to shut down that cluster if you're doing it manually, running all night, that is not cheap, and we don't like to see that. So.
One thing I'll say about that is there was no incremental cost to switching to SageMaker as far as I know. Because if we didn't use SageMaker, we would be using EC2 or ECS or something else anyways. So it's purely value add for us for a more specialized product.
What do you use for cloud payments, or what other cloud services do you use?
Cloud payments.
What do you do for payments, for example?
To take payments, we integrate with some third-party providers. We're currently using Stripe, but we've explored other providers in the past before.
I mean, as a startup, you want to be outsourcing some of the stuff. You don't want to be a payments company. You want to be a shipping logistics company.
We use a lot of third-party providers as a startup. Like, if there's anything we can buy rather than build, we'll buy it if it fits our use case.
Yeah, focus on building a product, not on this stuff. And last question, Steve wants to know, what's the spread between bid and ask for average deliveries? So what does the variance look like? What drives that variance?
The spread on a particular shipment, I don't know offhand, but what's the more interesting thing here would be like what's the overall variance, and it does vary up to 2 to 3 times. Like for example, if a hurricane hits a specific region, the cost of freight there can go up several times, 2 to 3 times more than kind of the average rate.
Do you guys analyze weather then to help anticipate that?
Yep, definitely.
Oh, that's fascinating. Huh. And what do you do to prep for like a possible hurricane situation?
So being a startup, we've only been around for 3 years, so we don't have too much data. So sometimes we just have to respond to it in real time as it's happening. But then we also do, as we've gotten more sophisticated and we've had more data, we're starting to get better at kind of predicting ahead of time and reacting ahead of time to these events.
That's fantastic. Well, thank you very much. Please, round of applause.
Thank you.